Welcome to the Explainer. Today, we're going to do something pretty cool. We're going to start with just a single, simple number, and from there, build a complete, detailed picture of a set of data. We're essentially going from a blurry, one-dimensional snapshot to a rich, detailed portrait.
All right, here's our game plan for today. We'll start with what I call the problem with averages. Then we'll get into measuring the spread. After that, we'll really start revealing the data's shape by looking at skewness and then kurtosis. And finally, we'll put it all together to create the complete portrait.
So let's kick things off with the tool that pretty much everyone reaches for first when they look at data.
Imagine this. You've got a huge pile of numbers, maybe thousands of test scores. How in the world do you boil all of that down to just one number? Well, our first instinct is usually to grab an average, right? A single value that we hope represents the whole group. And these are our main tools for that job. They're called measures of central tendency, which is just a fancy way of saying they try to find the center or the typical value. You've got the mean, which is your standard average, the median, which is the value smack dab in the middle, and the mode, which is simply the number that shows up the most often. But, and this is a huge but, here's the problem. Look at these two classes. They both have the exact same mean score, 85. But do they tell the same story? Not even close. Class A is super consistent. Everyone's clustered together. Class B is all over the place. Clearly, our single number, the mean, isn't giving us the full picture. So you see the issue. That center point alone can be really misleading. We need more detail. It's time to add a little depth to our portrait of the data. And this is how we do it. We use what are called measures of dispersion. Now, these don't tell us where the center is. They tell us how much the data spreads out around that center. This is how we actually measure that spread. The range is the simplest, just the difference between the top and bottom values. But standard deviation is the real powerhouse here. Just think of it as the typical distance any one data point is from the average. It answers the question, is our data tightly packed and consistent, or is it scattered and unpredictable? Okay, let's add our next layer. So far, we've got the center and we've got the spread. We know the location and the scale. But what are we missing? Well, we're missing the contour, the actual personality of the data. And this is the next critical question we have to ask. Is the data balanced? Is it distributed evenly on both sides of that average? Or is it kind of lopsided? This question takes us beyond just numbers and into the visual shape of it all. And this is where our data really starts to show its true colors. Is it nice and balanced, or is it telling a bit of a tilted, one-sided story? The word for this is skewness, and it's really just a measurement of that lack of symmetry. You know, in a perfectly symmetrical world, if you folded your data in half at the center, the two sides would line up perfectly, just like a mirror image. And here it is. This is our baseline, our perfect world, a beautifully balanced symmetrical curve. And notice something really important. The mean, the median, and the mode, they all line up at the exact same point, right there in the middle. But of course, the real world isn't always so perfect, and this shows what happens when it's not. Sometimes you get a few outliers that literally pull the distribution in one direction. That pull creates a long tail. If the tail goes to the left, we call it a negative skew. If the tail goes to the right, it's a positive skew. Now, here is the really practical takeaway. Check this out. With a positive skew, a few really high values drag the mean up, making it higher than the median. With a negative skew, the opposite happens. A few low values drag the mean down. This means you can just compare the mean and the median, and right away you can tell which way the data is tilted. It's a fantastic little diagnostic trick. Okay, time for the final detail in our picture. We've got the center, we've got the spread, and we know if it's tilted. So what else is there? Well, the height. How concentrated are all the data points right there around the center? And the term for this is kurtosis. It tells us if our data has a super sharp, narrow peak with heavy tails or a wide, flat peak with light tails. It's all about how much data is clustered in the middle and how likely you are to see extreme outliers. And this image, well, it captures the whole idea perfectly. You've got the three basic shapes. That one in the middle, the mesocurtic curve, that's our normal baseline. The really pointy one is leptocurtic, and the flat one is platycurtic. So, what does this actually mean? Well, if your data is leptocurtic, that really sharp peak, it means lots of values are clustered together, but those heavy tails mean there's also a higher chance for some crazy outliers. Platykurtic, the flat one, is the opposite. The data is more spread out, and the light tails mean extreme outliers are less likely. So let's zoom out and take a look at the rich, detailed picture that we've just built piece by piece.
Here it is, your complete toolkit. We started by asking, where's the center? That's central tendency. Then we asked, how spread out is it? That's dispersion. And finally, what is its contour? That's skewness and kurtosis. We've gone from one, often misleading number to a truly comprehensive description.
And you know, this isn't just theory for a stats class. This is the real language that people use to describe really important things: income inequality, stock market risk, scientific breakthroughs. Understanding these ideas lets you think critically and ask deeper questions than just, so what's the average? So next time you come across a chart or a statistic, don't just stop at the average. Ask about its spread, ask about its skew, ask about its peak, ask about its shape, and what story that shape is trying to tell you. Thanks for watching.